Okay, hello. Let's take a look at the first do now question, and it says you need to solve this particular triangle. That means we need to find the measurements of all three angles. We're given 1, and the length of all three sides, and we're given 2. But notice what exactly we're given. We're given this angle B as well as the length of the side opposite B. Therefore, we're able to use the lower signs. As long as we're given one other piece of information in which they gave us the length of AB. So with this, all we have to do is sub this proportion and solve. So we're going to write the sine of B, which is given, over the length of AC, which is also given. And what else is given? The length of AB. And then we just have to take a look at the triangle and say, hey, what angle is opposite side length AB? Which is C. So we write the sine of C. Let's substitute the values. So B is actually 56 degrees, AC is actually 17, and C, we don't know the measuring angle C, so write the sine of C, and AB we know, which is 14. So now all we have to do is cross multiply. So when we cross multiply, we're going to end up with 14 times the sine of 56 and 17 times the sine of C. So we have 14 times the sine of 56. Degrees is equal to 17 times the sine of C. Now the next step is to get C, isolate C. So we first have to isolate the sine of C. So we're going to divide both sides by 17. So 17 as well as 17. The 17s will cancel, leaving me on the left-hand side. I'm going to use the symmetry property to write sine C on the left-hand side is equal to, and I'm going to leave some space because I already see what's going to happen. I'm going to have to find the measuring angle C, so therefore we're going to have to use our inverse function. So I'm leaving a little space so I could just not have to rewrite it. So if I want to find the measure of the angle, I have to take the inverse, so the sine inverse of this, as well as the sine inverse on that. Whatever we do to the left, we must do to the right. Okay, so now let's go to our decimal calculator. Okay, so let's take a look. The first thing we have to do is write the sine inverse. So I'm going to hit the function because it's one of our functions. And we hit sine inverse. And then we also see that we're going to have a fraction. So we have to click the main button and click the fraction key. So now in the numerator we have 14 sine 56 degrees. Close the parentheses if we want. And then all over 17. That gives us approximately 43 degrees. So since we have that, we can go back here and type that in. The measure of angle C, and remember we're approximating, and that's about 43 degrees. Alright, so we just figured out that the measuring angle C is approximately 43 degrees, so now we can find the measuring angle A by using the triangle sum theorem. So since we know that the sum of the measures of any triangle will always add up to 180 degrees, we can write that the measure of angle A is equal to 180 minus the sum of the two other angles, 56 plus 43. So that means, well, approximately, because we're rounding. So approximately 180 minus, that should be 99. And then the measuring angle A is approximately 81 degrees. So now we have that portion done. So now the only thing that's left is to find the length of side BC. So we'll start off with what we started off the last time, because we were given the sine of B over AC. And now we're going to use the sine of A, since we just figured that out, over BC to figure out what BC is. So the sine of 56 over AC, which again is 17, is equal to the sine of A, which is 81 degrees, over BC, and that's what we're looking for. So once we have that, we can cross multiply. That leaves me with BC times the sine of 56 is equal to 17 times the sine of 81. We can divide both sides by the sine of 56. Divide both sides by the sine of 56. And that leaves me with BC, since this cancels, is approximately, and then we're going to substitute this into our decimal calculator. I'm just going to delete or clear all, and we need to write down the sine. Oh, I'm sorry. I'm going to have to write the fraction down first. Fraction 17 sine of 81 all over the sine of 56, which is approximately 20. And I said round to the nearest thousand, so we're going to round that to 20. We're going to take a look at this number, which is a 2, so that 3 stays the same. So 20.253. Alright? 5 or more raise the score. 4 or less, we're going to let that rest. And BC is approximately 20.253. So we have all 3 parts now. We have this side, this angle, and this angle. So now we have all 6 parts. So that means we solve this particular triangle. Thank you, and stay tuned for the next video.